Now let's create a simple shaft or stud where all the features, all the diameter, internal, external, cylindrical features are going to be a functional feature. Okay, we are going to start with the model. The model, let's take it as a shaft version 01. Okay, and as usual, all the shafts are created with revolve. Okay, revolve in the right plane. In the right plane, we are going to create the profile that's to be revolved. Okay, from here at a distance of 42.5 and 90 degrees. Okay, and from there 10 mm at 0 degree. Okay, and then it's down by 42.5 minus 20 mm, 25 mm dia. Okay, 0 angle. Let's see. Okay, sorry, it's 21.25 divided by 2, at an angle of 270. Okay, where it is gone. Okay, that one will just let us escape it. Let's draw one more line down by 22.5 at 270. Okay, and then it goes 18 mm. Okay, at 0 angle. Okay, and then um, down by, it's almost 25. Okay, down by 12.5 and at 270 angle. Okay, this goes to 75 mm at 0 angle, and then let's connect it with the horizontal axis vertically. Okay, this we will change it later. Okay, and this let's see. Okay, okay, then let's check one by one whether we have done the right stuff or not. It's terrible, but here we should have created a step. This one should come down. This one is 42.5. This one is right. This one is not here. Okay, let's make this one at, at 5 or 6 mm. Okay, and this one should be right, but this one is not 22.5. It's deleted. Let's give it later. And this one should be 12.5. 12.5. Okay. Anyway, this one should come down. Okay, this you delete it. This one, let's delete it. Okay, and there is a step here that should cover up to 42.5, 22. Okay, 25 means let's see, 42.5 minus 25. That's right. 17.5 to 70. Okay, from here to here. That's right. See how it comes. Close it. This one. Let's keep it 17, 18. Okay. And what else? Okay, from these 2 points, let's make it coincident. This point and this horizontal axis. Apply it. Okay. Okay. Close it. Now everything looks fine, right? Yes, let's wind it up. Okay. The sketch is fully defined. Let's take this up and this one closer. Okay. Okay. It all seems fine. Okay. Let's go ahead and revolve it. Revolve it. Okay, now we are going to select the vector and going to specify the point about which it's going to be revolved. This is a simple shaft, it looks. Okay, and let's create two more revolves. Okay, and revolve and the same plane, no problem, because we are not constrained it there. Let's draw a small rectangle. Okay, and let's give its dimension to the horizontal axis first. That is okay, 25 means let's keep some 3 mm. Okay, okay, 3 mm then. Okay, no problem. 22. Yes, and from here to there. This one is okay. From here to there, it should be let's take it 36 or 35. Okay, leave it, no problem. Then this dimension, this dimension is, we are going to subtract it. Let's specify it. Okay, and then let's specify this also. Okay, this one, let's keep it 6. Now okay, now this dimension from this to horizontal, it's 25, right? Let's keep it where there is a circlip going to be assembled. Okay, it's 12.5. Let's keep it 10. Okay, and from this to this, it is total 100 and too heavy. We did add some mistakes. Let's see later. Let's keep it around 105. Okay, and for circlip, this distance between these two line segment should be 1.5. Okay, and let's restrict this dimension to 3, more than sufficient. Okay, okay, this is for circling. Now sketch is fully defined. Let's exit the sketch and revolve it. Okay, now specify the vector and the point should be the same, but this time the Boolean operation is to subtract. Apply. Okay, now we have to create hole in this plane, front plane. The front plane some 8 hole pattern, but the point, let's sketch it. This point, let's draw a circle at approximately 58. Okay, this circle, let's keep it as only reference, and then let's make this point coincident on this. It's not happening. Okay, okay, then let's move this point. It's already placed, that's why it's not moving. Now it will move this point to this. Apply. Now draw a line from these 2 points. Okay, this point also, let's keep it reference element. Okay, now let's give the angular dimension between this line and the vertical axis at 22.5. Okay, now that hole sits at the right position, the sketch is fully defined. Yes, no warning. This hole has 3 mm hole dia, no problem. That's what we want. We want 6 m depth, angle, everything seems fine here. Yes, already done the similar stuff. Then we have to do a circular pattern of this hole about the vector and the point is same. Origin, yes, same. 8 count and 360 divided by 8. Okay, that's all. We have created the part. Okay, the real stuff we are going to learn in this is creating a 2D drawing with GDNTs. Okay, okay. And the one more feature in the front plane, okay, we are going to create a slat of 6 mm. Between these two line segments, it is 6 mm. Yes, okay. And as usual, let's first constrain these to this It should be somewhat 16 mm. Okay, and then this is between the vertical axis. Now between the horizontal axis, it should be 6 divided by 2, right? Yes, leave it. Okay, let's keep it 3 mm. Why we are parametric things? Yes. Okay. Now let's draw a circle that should be 3 point tangent to this line and tangent to this line and again tangent to this line. Okay, let's see if it is not working. Then let's apply between these two. Apply. And then again one more time. Let's apply. Okay, now these three edges are tangent. Let's quickly trim this unwanted edges. Okay, now close it. Now unfortunately again we have to constrain to the vertical axis, but this time we know it should be 85 above. So 45, yes, it works. And still it has three movable parts. The only stuff here we have to constrain is this one. Okay. The fully constrained sketch fully defined. The sketch is fully defined now. Let's extrude it out. Let's create in the reverse direction by 5 mm. Okay, that's all. Now let's give the part modeling. Okay, okay. Let's give some nice color here. Okay,